Ionic equilibrium. So, crash course-ல நம்ம அடுத்ததா பார்க்க போற டாபிக் ionic equilibrium. சரி. So, what is ionic equilibrium? Very simply speaking, it is nothing but equilibrium involving ions. Where do you get ions? Simply cations and anions. Where do you get from salt? How do you get salt? Acid, when neutralized by a base, gives salt plus water. So, when you before going to the lesson, we have to get a very clear knowledge about these two acids and bases. What is an acid and what is a base? சார் நாலு பேர் நாலு விதமா சொல்லியிருக்காங்க சார். ஆசிட்னா என்ன, பேஸ்னா என்னன்னு நாலு பேர் நாலு விதமா சொல்லியிருக்காங்க சார். அத நாலு பேரை பார்ப்போம். மூணு பேர் தான் இங்க. The first person is Arrhenius. So he put a theory on acid and bases that is called as Arrhenius theory. The next person is Lowry-Bronsted. So it is called as Lowry-Bronsted theory. The third one is the well-known Lewis theory. So look at the first one, ma. According to Arrhenius, acids are substances that give H plus ions in water. Acids are substances that give H plus ions in water. Upper bases they give OH minus ions in water. So, according to him, water is considered as a neutral substance. That is why he told those which give H plus in water, OH minus in water are acids and bases. Likewise, he told. So, according to Arrhenius, water is a neutral substance. Water is a neutral substance. Right. I'll move on to the next one. Sir, Lowry Bronsted. What did they tell, sir? They told proton donor, H plus donor, either it can donate in water or it can donate in any other solvent, whomsoever it may be. Proton donors are acids and proton acceptors are bases. So, according to him, water can act as a proton donor as well as proton acceptor. So, water is amphoteric. Water is amphoteric. It can act as a proton donor. It can act as a proton acceptor. I'm going to explain you each one by one below. Don't worry. Sir, according to Lewis, what is an acid, sir? It is a different theory. Electron acceptors are acids and the electron donors are bases. And according to him, water is the electron donor. So water is a base according to Lewis. According to Lewis, water is a basic substance. It is not an acidic substance or a neutral substance. According to Lewis, water is basic substance. So we are going to see all these one by one, and especially I will start with Lowry-Bronsted theory. So they put a thing called conjugate acid base pair concept. Sir, what is this conjugate acid base pair concept? Let me take a base ammonia. Let me take a base ammonia. Okay. I am adding ammonia in water. What will happen? Sir, ammonium ion and OH minus ion is formed, sir. Okay. I am adding HCl in water. What will happen? Sir, H3O plus and Cl minus is formed. Super. Listen to the screen carefully. This fellow is proton donor or proton acceptor. Sollu. Donor acceptor. Donor. This fellow is proton acceptor. This fellow is proton donor. This fellow is proton acceptor. Very good. அடுத்தது. Next point. Proton donors are called as acids. Proton donors are called as acids. Proton acceptors are called as bases. So, what is the role of water in the first reaction? Sir, the role of water in first reaction is proton acceptor, base, sir. Whereas in second reaction, it is proton donor, acid, sir. That is why water is amphoteric. That is why water is amphoteric. And next thing, look at this and this. Look at this and this. They are called as conjugate acid base pair. They are called as conjugate acid base pair. So H2O would a pair H3O plus. This is acidic and this is basic. இவனோட conjugate acid இது, இவனோட conjugate base இது. புரிஞ்சுதா? புரிஞ்சுதா? Similarly, HCl and Cl minus இவன் தான் ஆசிட் ஏன்னா ஒரு H plus அதிகமா வச்சிருக்கான். இவன் தான் பேஸ். கிளியரா? அதே மாதிரி பாருங்க அமோனியா with ammonium H2O with OH minus தனியா எழுதி காட்டுறேன் பாருங்க ammonia with ammonium. This fellow is acid. This fellow is a base. They constitute a conjugate pair. Next one, water OH minus. This is acid. Extra or H plus ion. This is base. So there are 4 conjugate acid base pairs in screen. There are 4 conjugate acid base pair. And all these pairs, what is the difference between them? The difference between them is only one H plus ion. Look at what is the difference between these two. Sir, only one H plus ion. Sir, what is the difference between these two? Only one H plus ion. Sir. So a conjugate acid base pair differ by only one H plus. Only one H plus. Right. With that, they are not stopping with that. They are proceeding further. What is further reaction? Johnny? This is a base. When treated with water, forms NH4 plus and OH minus ion. This is an acid. When treated with water, forms base plus OH minus ion. Sorry, H3O plus ion. Sorry. So this is a base and this is its conjugate acid. This is a base and this is the conjugate acid. So this is the reaction of base and this is the reaction of conjugate acid with water. With water. I am writing the equilibrium constant. Equilibrium constant is equal to concentration of NH4 plus product into OH minus by concentration of ammonia. I am not taking water because concentration of water is a constant. This is base na. So I am mentioning this as Kb. I am mentioning this as Kb. Here it will be Ka. Concentration of ammonia into concentration of H3O plus by concentration of ammonium plus. I am multiplying Ka into Kb. Look at the equations. Sir, this is at the bottom, this is at the top. They will cancel each other. Above and below cancel each other. What is final? H3O plus into OH minus. Do you know what is this called as? இதுக்கு என்ன பேர் தெரியுமா? Ionic product of water. What is this called as? Ionic product of water. சொல்லுங்க, what is this called as? Ionic product of water. Okay. Do you know what is the value of ionic product of water? At 25 degrees Celsius, Kw is equal to 10 power minus 14 mole square liter power minus 2. Mole square liter power minus 2. This is the value of ionic product of water. This is the value of ionic product of water. இதுல யாருக்காவது ஏதாவது சந்தேகம் இருக்கா? அடுத்தது போட்டுமா? சீக்கிரம் நிறைய வேலை இருக்கு. அடுத்தது போட்டுமா?
Yes, sir.
Right. நல்லா கவனி. அப்ப Kw னா என்ன? Concentration of H plus into concentration of OH minus ions present in water. It is equal to 10 power minus 14. Right. In water they are equal, right? In water they are equal. So I can write Kw is equal to concentration of H plus square அப்படின்னு எழுதலாம். Or concentration of OH minus square அப்படின்னு எழுதலாம். I can write in any way. சரி, அடுத்தது. I know Kw is equal to concentration of H plus into OH minus. This is equal to 10 power minus 14. Now I am multiplying this equation by minus log on both sides. Minus log of Kw equal to minus log of H plus minus log of OH minus equal to minus log of 10 power minus 14. This is called pKw. pKw now minus log of Kw னு அர்த்தம். This is called pH plus pOH. This is pH. This is pOH. I think you know pH, right? pH ஓட ஃபார்முலா தெரியும் இல்லையா? அதே மாதிரி pOH ஓட ஃபார்முலா மைனஸ் லாக் ஆஃப் OH மைனஸ். இதெல்லாம் உங்களுக்கு தெரியும் தானப்பா? இதோட ஆன்சர் 14. இதோட ஆன்சர் 14. ஸோ இந்த ஸ்கிரீன்ல பாரு எவ்வளவு புது ஃபார்முலாஸ் வந்துட்டே இருக்குன்னு பாரு. ஸோ PKW அப்படின்னா PH பிளஸ் POH இட் இஸ் ஈக்குவல் டு 14. இட் இஸ் ஈக்குவல் டு 14. இதுல யாருக்காவது ஏதாவது சந்தேகம் இருக்கா? இருக்கா?
No, sir.
நோ. இதெல்லாம் எப்ப? 25 டிகிரி செல்சியஸ்ல. லிசன், அட் 90 டிகிரி செல்சியஸ் டெம்பரேச்சர் அதிகமான டிகிரி ஆஃப் டிசோசியேஷன் தான் இருக்குது, இன்க்ரீஸ் ஆகும். பாரு அப்ப கவனி, வாட்டர் giving into H plus ion and OH minus ions. So when temperature is increased, H plus ion will increase, OH minus ion will increase. Will increase. Therefore, what they have calculated now, at 90 degrees Celsius, Kw is equal to 10 power minus square, sorry, minus 12 mole square liter per minus 2. Mole square liter per minus 2. Look at the screen carefully. Boys and girls, look at the screen carefully. Look at the two values. Look at the two values. And now I'm going to ask you a question. What is the value of pH of neutral water at 25 degrees Celsius? pH of neutral water at 25 degrees Celsius? 7. pH of neutral water at 90 degrees Celsius? 6. ஏன்னா இதுல பாதி. Because here also pH plus pOH is equal to PKW is equal to 12. ஏன்னா it is 10 power minus 12 now. புரிஞ்சுதா? புரிஞ்சுதா?
Yes, sir.
What is the pOH of neutral water at 25 degrees Celsius? At 25 degrees Celsius, it is 7. At 90 degrees Celsius, pOH is equal to 6. Are you able to get the point? So, so at 25 degrees Celsius, pH 7 is neutral. At 90 degrees Celsius, pH 6 is neutral. You just keep this in mind. Sometimes questions may be asked from this area. I'll move on to the next. Without wasting time, I'm going next. Don't worry. Try to understand. I'm going to teach you about Oswald dilution law. This law is applicable only for weak electrolyte. Come on, tell me what is a weak electrolyte, ma? What is a weak electrolyte?
Which has weak acid and weak base in it
Why it is called as weak?
because it cannot produce H plus ions.
It cannot produce a. அப்படி சொல்ல
Sir,
வேண்டாம்.
complete dissolve ஆகாது sir.
It cannot give it cannot give all the H plus ions. அப்படி சொல்லலாம். ஓகேவா? So strong, weak அப்படின்னு ரெண்டு இருக்குப்பா. Strongனா complete dissociation. So it will give all the H plus ions. Strong acid அப்படின்னா it will give all the H plus ions it is having. அதுவே weakனா partial dissociation. It will give H plus but not all the H plus. But not all the H plus. சரி, ஓகே. பாருங்க, இதுக்கு சில டெரிவேஷன்ஸ். why we are doing itனா, for a strong acid வச்சுக்கோ, degree of dissociation alpha equal to 1. Degree of dissociation alpha equal to 1. But for a weak acid, for a weak acid, alpha value is less than 1. Alpha value is less than 1. So how to calculate the alpha value? For that thing, we are developing this law called dilution law. Let me explain you with the weak acid, acetic acid, which breaks down into acetate ion and H plus ion. Initial number of molecules reacted, remaining concentration. So 1 mole initially present. X moles reacted. X is taken as alpha here. Here X is taken as alpha. Remaining 1 minus alpha, alpha. Concentration. Concentration number of moles by volume. Number of moles by volume. Number of moles you have taken initially taken is 1 mole. So 1 by V. So instead of writing like this, one number of moles by volume, instead of writing like this, 1 by V can be replaced by C. I can write C into 1 minus alpha, C alpha, C alpha. புரிஞ்சுதா? ஓகேவா? Now what is the formula for equilibrium constant? Sir, concentration of product by concentration of reactant, sir. Solve பண்ணிக்கோ. Final answer I am ready. Alpha square C by 1 minus alpha. Alpha square C by 1 minus alpha. Look here. If alpha is very small, alpha is a very small number, Ka equal to alpha square C. That's it. Denominator becomes 1. Alpha square equal to Ka by C. Then alpha equal to root of Ka by C. Is there any doubt? Is there any doubt? Right. Look at this tabular column and answer my next question. What is the concentration of H plus? What is the concentration of H plus? Look at the tabular column and answer my question.
C
C
alpha.
alpha. C alpha. Very good. C. Instead of alpha, I can write Ka by C. Okay. I can simplify and write Ka into C. So this is the concentration of H plus now. Is it clear for everybody?
Yes, sir.
பாரு கடைசியா ஒரு step. Multiply this equation by minus log on both sides. Left hand side minus log of H plus equal to minus log of Ka into C power 1 by 2. 1 by 2 is taken to the front. Log Ka plus log C. Right? நல்லா பாரு. Minus half log Ka minus half log C. This can be written as half pKa minus half log C. So finally, this is written as pH. This is written as pH. So pH is equal to half pKa minus half log C. இங்க பாருங்க எத்தனை formulas பார்த்திருக்கோம் பாருங்க. I will highlight the formulas now. First formula, alpha square C by 1 minus alpha. Second formula, Ka equal to alpha square C, alpha equal to root of Ka by C. Then concentration of H plus equal to C alpha. Then concentration H plus equal to root of K into C. Finally, pH formula. So, by means of a very simple derivation, we are arriving 4 to 5 formulas. இது எல்லாருக்கும் புரிஞ்சுதா?
Sir, C into 1 alpha, 1 minus alpha also.
இதுவா தம்பி?
Yes, sir. எப்படி வந்துச்சு?
Right. Concentration என்ன பண்ணுவோம்? சார் இதான் சார் நம்பர் ஆஃப் மோல்ஸ் 1 minus alpha number of moles by volume. Number of moles by volume தான் concentration. கரெக்டா? Yes.
Okay.
Concentration no formula இருக்கு பாரு. N by V. N by V. N க்கு 1 போடலாம். 1. N க்கு 1 போடலாம். 1 by V. அப்ப 1 by V க்கு பதில் C யூஸ் பண்ணிக்கலாம். அதனால தான் இங்க பண்றோம். 1 by V இதுக்கு பதில் C போறோம். புரிஞ்சுதா?
Okay.
Right. ஓகேப்பா. So osmolar dilutionல for weak acid ஸ்கிரீன்ல தெரியறது ஒரு வீக்கான ஆசிடுக்கு ஆல்ஃபா osmolar dilutionல. இதே ஒரு வீக் பேஸா இருந்தா for weak base பாரு Kb equal to alpha square C by 1 minus alpha first formula. Kb equal to alpha square C ரெண்டாவது formula. Alpha equal to root of Kb by C மூணாவது formula. Concentration of OH minus equal to C alpha நாலாவது formula. ஏன்னா பேஸ் OH minus வரணும். அடுத்தது கடைசியா POH is equal to half pKb minus half log C. So all the above formulas, when we rewrite it for a base, it will be like this. புரிஞ்சுதா? இதை யூஸ் பண்ணிலாம் ப்ராப்ளம் நிறைய நம்ம சால்வ் பண்ண வேண்டிய நிலைமை வரும். புரிஞ்சுதா? அடுத்தது போலாமா? எஸ், ரைட், வெரி குட். அடுத்ததா என்ன சார் பார்க்க போறோம் அப்படின்னாக்கா காமன் அயான் எஃபெக்ட், ஆட் அயான் எஃபெக்ட், ரெண்டு எஃபெக்ட் பார்க்க போறோம். Common ion effect, odd ion effect. Sir, what is a common ion effect and what is a odd ion effect? That I will explain you with an example. This is a weak acid, so it splits partially. Sorry, H plus. Okay, and again, so in two containers, I am taking acetic acid. I am dissolving it in some water. So all the three substances will be present. Now I am adding sodium acetate, which is a strong salt. Weak acid na அதோட conjugate base ரொம்ப ரொம்ப ஸ்ட்ராங்கா இருக்கும் இல்லையா? ரொம்ப ஸ்ட்ராங்கான கான்ஜுகேட் பேஸா இருக்கு இல்லையா, ஸ்ட்ராங்னா கம்ப்ளீட் டிசோசியேஷன், கம்ப்ளீட்டா பிரிஞ்சிடும். இந்த மாதிரி ஆயிடுச்சு. இங்க I am adding sodium hydroxide which is a strong base. Strong means இப்படி யாரோ போடக்கூடாது, இப்படிதான் யாரோ போடணும். Na plus OH minus. In these two cases, look what happens in these two cases. In first case, there is a common ion. There is a common ion. So look here, this is a reaction, reactant to product. Common ion means I am increasing this. That means I am adding product. I am adding product. What happens to the first reaction? It goes to the left hand side. It goes to the left hand side. So by common ion effect, first reaction goes left. புரிஞ்சுதா? புரிஞ்சுதா? Right. Next, look at the second reaction. There is no common ion. There is no common ion. But this fellow will be removed by OH minus. They too will react. Both of them will react. Both of them will react. That means by odd, this is the odd ion. By odd ion effect, first reaction goes right side. Right side. Here, dissociation of first reaction. Dissociation is decreased by common ion effect. பாரு, இப்படி போனதுக்கு dissociation. Forward reaction is dissociation. Here, dissociation is decreased. Whereas here, dissociation is increased. So, dissociation is decreased by common ion effect. Here, dissociation increased by odd ion effect. புரிஞ்சுதா புரியலையா? அடுத்தது போலாமா?
டிசோசியேஷன் மட்டும் சொல்லுங்க சார்.
டிசோசியேஷன் என்ன? இப்படி ஒருத்தன் இருக்கான், அவன் உடையறான். He is getting splitted. This is called as dissociation. This is called dissociation. The same thing இங்கேயும் பாரு. Forward reaction is called dissociation. Forward reaction is called dissociation. So forward reaction decreases in this case, whereas forward reaction increases in this case. Okay. Right. Next. What happens because of this common ion effect? We are going to explain about buffer solution. Sir, what is a buffer solution, sir? Right. Normal solution. Normal solution. If you add acid, pH will decrease. If you add base, pH will increase. But buffer solution, they resist pH change on adding acid or adding base or adding water or on long standing. Long standing means it is made and it is prepared and it is left as such for a long time. As such for a long time. So buffer solution acid add பண்ணாலும் base add பண்ணாலும் water add பண்ணாலும் pH மாறாது. They will resist pH. They will not change in pH. This is also only for small amount, for certain amount only. You cannot add liters and liters of an acid. You can add only a small amount. Okay. So that solution is called as buffer solution. There are two types of buffer solution. One is called as acidic buffer and another one is called as basic buffer. Acidic buffer என்ன சார் அப்படின்னாக்கா weak acidum அதோட strong conjugate baseம். Basic bufferனா weak baseம் அதோட strong conjugate acidum. This is nothing but salt. Similarly here this is nothing but salt. I'll explain with an example. Weak acid, acetic acid. It will be weak. Weak na partial dissociation. To this I am adding strong conjugate salt, sodium acetate. Strong conjugate salt, sodium acetate. So this constitutes a buffer. This is a buffer. Similarly, basic buffer, weak base, ammonium hydroxide, ammonium ion and chloride ion. And its strong conjugate salt, ammonium chloride. Ammonium ion and OH minus. இங்கே தான் அம்மோனியம் அயான் குளோரைடு அயான். இது வரைக்கும் புரிஞ்சதா? Shall I go for the next step? Right. Now I'm going to explain you how a buffer operates. I'm going to explain you buffer action. How a buffer is maintaining its pH அப்படின்னு சொல்ல போறேன். சரி பாரு. This is taken in a beaker பா. This is acidic buffer and this is basic buffer. Okay. If you add acid, if you add acid, okay, add acid. What happens now? The H plus ions which you are adding combine with this and it is converted into acetic acid. It is converted into acetic acid. By this forward balancing mechanism, to some extent, it will resist the change in pH. Similarly, if you add H plus to the right side, it will combine with the base, acid will combine with base, and it will form ammonium ion plus water. Water is formed, neutralized. The acid is neutralized as water. So the pH will not change. So the pH will not change. Sir, suppose if I add base, sir, what will happen, sir? Suppose you are adding base. Base OH minus. That will combine with acid and it will form CH3CO minus and water. So your base is neutralized as water. Suppose you are adding base here. It will combine with ammonium hydroxide and by the forward equilibrium it will maintain the pH. It will maintain the pH. So the H plus ions or OH minus ions are neutralized in buffer solution. So the added H plus ions or OH minus ions are neutralized in buffer solution. They are neutralized. So buffer solution maintains pH. இது புரிஞ்சதா எல்லாருக்கும்? Now, finally, I'm going to speak about another thing called as buffer capacity. Sir, what is a buffer capacity, sir? It is nothing but you can add acid, small amount of acid, pH will not change in some yeah. How much you can add, that extent it measures buffer capacity. So there is a formula for buffer capacity. Number of moles of acid or base added per liter of solution, per liter of buffer divided by change in pH. This is the formula for buffer capacity. If buffer capacity is more na, that buffer can work better. Buffer is better buffer, good buffer. Okay? Good buffer, better buffer, எப்படி வேணா சொல்லிக்கலாம். So, ஒரு buffer pH மாறாம பாத்துக்குது. எப்படி பாத்துக்குது? Added ions are neutralized in some way. In any other way, it is having a lot of ions in it. By using the ions, the added ions are neutralized. Added ions are neutralized. சரி, அடுத்ததான் இந்த யூனிட்ல என்ன சார் பார்க்க போறோம் அப்படின்னா salt hydrolysis. This is a important thing. What is meant by salt hydrolysis, sir? Right. Whenever an acid is treated with a base, you will get salt and water. Have you ever thought of the reverse reaction? Think of the reverse reaction. Salt plus water gives acid plus base. This is called salt hydrolysis. So salt hydrolysis is nothing but the reverse of neutralization reaction. Salt hydrolysis is nothing but the reverse of neutralization reaction. Right? So salt hydrolysis and solubility product. Two simple points are remaining that we will see tomorrow morning.